Okay, so the review. Our first one, determining if these figures are polygons. So we had 3 rules for this. Do the lines intersect anywhere else other than the endpoints? Is it a closed figure? Is it formed by segments? So in our first picture, is that a closed figure?
Yes.
Is it formed by segments?
Yes.
Do the endpoints overlap? So, hold on. The endpoints overlap, but does it intersect anywhere other than at the endpoints?
No.
So we see we have kind of like 2 pictures together. I feel like this one's a little sketch because I feel like you could argue that this could potentially be a diagonal, or you could say it's 2 triangles. I classified this as not a polygon because we have this overlapping here. So I said no to our first one. How about our second one? Yep, yes, and then how many sides does it have? No intersecting sides. Okay, what'd you get? Yes. And how many sides? You had 13. How many did you have?
I didn't count.
How many? You had 13? Okay, so we had 13 sides. So 13 gone. Okay, so we have 14 gone. So remember, we have names for like a 12 gone. But we didn't learn those specifically. So anything over 10, I allowed you to just use the number and then the gone. Our second half here. Number 3, what'd you say? No, how'd you know? No, it's curved. Not formed by segments. Okay, number 4. And how many sides do we have? 4. So what do we call 4-sided shape? Oh, be careful. That's a specific kind. A more general term for 4-sided quadrilateral. Okay, now we're over here and we have to find the missing angles. So we're solving for x. What is the sum of the interior of a quadrilateral? 360. So we're going to add up all of our angles and set them equal to 360. So I ended up with 82 plus 105 plus 8x plus 11 plus 10x equals 360. We're going to combine our like terms. So 82 plus 105 plus 11. What did you guys get? 198. 198 plus 10x and 8x combined to give me 18x equals 360. We have to combine our like terms, so things that don't have x's and things that do. So I'm going to subtract the 198 to the other side. 18x equals 162. X equals 9. Thank you. Okay, so this question only says to solve for x. So x equals 9. That's what this blank should say. Okay, number 6, same idea. Remember, the right little corner marks tell you that these are right angles. So you're going to add these up. You have 90 plus 90 plus 16x minus 6 plus 15x equals 360. I wrote big, so I apologize. Okay, so 90 plus 90 minus 6. Yep, we have 174 equals, combine my other like terms, the x's, 16x and 15x. Yep, 31x, nice job guys, equals 360. Combine the constant terms again because those are things that don't have x's, so get like terms together. Ooh, give me 1 second. Okay, so I have 31x equals, how much did you get for the other subtraction? 186. Okay, and then you divided by 31, and what did you get, hon? 6. Okay, and then our last one, you guys can move faster than me probably, so let's do 95 plus 10x minus 5 plus 95 plus 8x plus 13. Combine like terms equals 360. So 95 plus 95 is 190 plus or minus 5 plus 13, what'd you get? 498 plus 18x equals 360. Subtract 198. We have 162. Divide by 18. X equals 9. Okay. I'm going to clear this page that we have 360. So you want to find the measure of angle A. It's missing that little part, the measure of angle A portion. So you have the 360 minus, you add up the remaining angles, and you're going to solve. So when you put those together, you have 360 minus, add those three angles, what'd you get?
290.
Yep, did you get 290?
Yeah. 289.
I got 289. So when you do 360 minus 289, 71 degrees. Nice job, guys. Good teamwork. Okay, over here, we have the same setup. 104 plus 10x minus 4 plus 76 plus 104 equals 360. Combine our like terms. What do we get? You get 280 equals? Or is that the whole thing? Okay, thank you. Sorry, I just wasn't following. 360. Subtract your 280 over. Can you? Okay, I'm up high. So you end up with 10x equals 80, you said, hon? Divide by 10. Yep. Oh, x equals 8. I jumped ahead. So x equals 8, but that's not what this question's calling for. It's calling for the measure of angle W. So we have to substitute that in. You have 10 times 8 minus 4. 80 minus 4, which is 76. Okay, over here, you have the 14x minus 7 plus 11x minus 2 plus the 93 degrees plus 76 equals 360. Combine our first part, so you ended up with 25x, negative 7 minus 2 plus 93 plus 76. I got 160. Does that sound right? Okay, double check my math. Equals 360. Subtract over 160. I have 25x equals 200. Divide by 25. X equals?
8.
We're going to substitute 8 back into whichever angle we're trying to find, angle L. So that's going to be 14 times 8 minus 7. 105? So 105 degrees. The first question is tell how many sides this polygon has and then classify it. So how many sides does it have? Yep, it's 8 sides, so that means it's an octagon. Okay, so we have octagon. State 2 ways to name this polygon using the vertices. We did this yesterday with trapezoids, but we didn't do it with an octagon before. So we'd call it octagon. And then you're going to list all of the vertices. So you have P, Q, R, S, T, U, V, W. Or you can say you have octagon. And these are just 2 examples. There's numerous ways to do this. You could also have octagon. And I did S, T, U, V, W, P, Q, R, S. So those are 2 options, but again, it's just as long as you count for all the vertices. We generally make sure we go in a row, but you can pick any starting point. And then our second one is name all of the diagonals that start at vertex T. So remember, this is what connects the vertex, our vertices. So we have 1, we have 2, we have 3, 4, 5. We don't count the ones that connect S and T and U and T because that's actually the side. So we're going to name those just like we've done before. So you have TR, TQ, TP, TW, and TV. Do we miss any? Okay, so we also have sketch the following. Figure that is not a polygon because one of the sides is not a segment. So this is up to you. Yours don't have to match mine. I'm just going to draw a quick picture, but whatever you'd like works for me. So then it says draw 2 different types of hexagons. So remember, hexagons have 6 sides. So, ooh, I don't like that. So that's one version of a hexagon. Yours, again, does not have to look like mine. And then you can draw a second hexagon, again, with 6 sides. So, don't want to be connected. Pentas 5. So, a pentagon A, B, C, D, E with all diagonals from vertex D. So, I drew my pentagon. Hold on. And then you have to label it because it actually asks you specifics. So you have to have A, B, C, D, E. And then it's all the diagonals from D. So mine looked a little like this. Is this what yours looks like? Or similar with your shape? So we're trying to see if it's a parallelogram. So is the first one, 19, a parallelogram?
Yes.
How do you know?
Because the opposite angles are congruent.
Yes. Opposite angles are congruent. Okay, how about the second one? Is there enough information?
No.
No, there's not enough information. Not enough information.
We just write no. Yeah.
And the reason we know this is because there's only one pair of parallel sides.
No.
Only.
The next one is no. Nine.
Give me 1 second. Okay, number 21. It's no. How do you know that, Montu?
They don't have no congruent sides.
Yep, we only can see one pair of congruent and one pair of parallel sides. Not enough info. Which part? Okay. Yes. How do you guys know? Yep, both not congruent. Both pairs of opposite sides are. Okay, are parallel. And then we have this one here. How would we know if this is a parallelogram? So that, I like your strategy. This is the one you took before. So she's going to check it by seeing if you do the 360 minus the 2 angles you have, the 3 angles, and see if it gives you 115. So will it?
Yeah.
You do get 115. And so this is 115. And then she could say yes, because opposite both pairs of op angles congruent. The other way of doing this is where you wouldn't have to do that is just take the angle that's in the middle, the 115, and add it to 65 because those are the 2 consecutive angles. Remember what parallelograms, consecutive angles are supplementary. So as long as on both pairs it adds up to 180, you're good to go. And then our last one on this page, is this a parallelogram?
Yeah.
And how do you know?
The diagonals are bisected.
Yep, diagonals are bisected. Okay. We have the first one is a parallelogram. We want to solve for x. How do we go about solving for x in the first one since that's a parallelogram? So we don't necessarily need to use 360 in this one. What do we know about opposite angles?
They're congruent.
They're congruent. So all I have to do is take the 5x minus 9, set it equal to 3x plus 11, and then solve for x. So group my things together. I end up with 2x minus 9 equals 11. Add 9. I'm going to go up here so we have space. I end up with 2x equals 20. Divide by 2. X equals. Did you guys get 10 as well?
Yeah.
Okay. So our second question here tells you it's a rhombus. What do we know about rhombus? Or rhombuses? All sides are congruent, and this gives you two sides. So to solve for our variable, all we're going to do is set our two sides equal. So you have 2y plus 3 equals 5y minus 6. You can group things together, so we're going to put our like terms, subtract 2y. This gives me 3 equals 3y minus 6. I got to get that minus 6 to the other side. I started really low, so I apologize. I'm going to bring it up here. So I have 3 equals 3y minus 6. Is that what I have?
3y
Okay.
minus 6.
Add 6 to the other side.
Add 6.
I have 9 equals 3y. Yep, we get y equals 3. Okay, and then the last one on this group is, oh, it's not. We have 3 more. Okay, so it's a parallelogram, and it tells us KU. So this portion here is going to be 3x plus 3. Can you read that? Kind of, okay. And it tells you UM is 4x minus 4. This makes you remember the properties of a parallelogram. You know in a parallelogram that the diagonals are bisected. So that means that KU is going to be equal to UM. So we can take 3x plus 3 equals 4x minus 4. Combine our like terms, subtract 3x. I end up with 3 equals x minus 4. Add 4. X equals 7. So, on the next question, number 28, it wants us to find y. We have a property about rhombuses that tells us about something that happens with the diagonals. Does anybody remember this property? Yep, so the diagonals are perpendicular. That means that this is a right angle. So, since we have that, to find y, what's the sum of the interior of a triangle? So we have 180 is going to equal y plus 90 plus 48. So we have 180 equals y plus 138. So you had to know those properties. Those properties are going to continually coming back. We're going to subtract over the 138. We end up with y equaling 42 degrees. This one tells you it's a parallelogram. What type of angles do we have here? These are, starts with a C. Maybe not congruent. What's it? Consecutive. And we know consecutive angles add up to 180, which is a lot. So we know it adds up to 180. Remember, consecutive angles line next to each other. So that's going to be 70 plus 11x equals 180. Subtract over 70.
I got a question.
Yes, ma'am.
Why is it 180? I thought you said that was for a triangle.
So this is because it's consecutive angles. It's just half of it. So the whole thing's 360, and each two angles that line next to each other have to add up to 180. So these two add up to 180. These two add up to 180, and when you add them together, it's 360. Okay, so we have 110 equals 11x. Yep, so we see that x equals 10. Okay, and then we have our last one, which goes right back to what Janelle just read to us. This again is a rhombus. And what do we know about the diagonals in a rhombus? They're perpendicular. which means that x here also has to be, yep, it also has to be 90. So x equals 90 degrees. And that's by the property. So once again, we have a rhombus, and we know that consecutive angles are going to add up to 180. So you have 180 minus 130. So x is going to be, x has to be 50 degrees, yep. So we see here this is going to be 50 degrees. This is a parallelogram, so you know that these two are congruent. So that means that 2x equals 10. Divide by 2. X equals?
5.
Yep. And over here, this is a parallelogram. What do we know about opposite sides in a parallelogram? They're congruent, so that means we can set our two sides equal to each other. Subtract 15. I end up with 2x equals x. I'm going to subtract over my x. I end up with x equals, be careful. What's x minus x? X is going to equal 0. Our next one, this is good we're doing this because it didn't draw in the diagonals, so please make sure you draw in your diagonals. So take a second and add those in. You have a number of problems on your test like this tomorrow, where you're going to be given blanks to fill out, and you're going to find the measures of the angles, the lengths of the diagonals, the lengths of the other sides. So just beware. So this is a parallelogram. It wants you to find the missing angles. So over here, there is one other angle that was not given that you need to add in to solve this. This right here is 28 degrees. You have to have that to solve this. Would you guys like to take about 30 seconds and try to solve a few of them on your own?
Sure.
So now that we're here, I'm going to change my color so you can see that I'm writing it somewhere else. So we have two sets of parallel lines, these, and they're being cut by a transversal. Two of them, actually. So what do we know about the relationship between these two angles? They're going to be the same because it's opposite interior. So I know this one up here has to be 62. Let's go back, 62. And then over here, if this is 28, what do we know about this relationship? It's going to have to be 28 because, again, it's alternate interior. And then if this is 36, we know this one has to be 36. Okay, so we can figure out the sum of this whole angle. So what is the total angle CAR? So it's 28 plus 36. So we have this whole thing as a 64-degree angle. And we know that either of these two angles are consecutive angles. So we know that this angle and this angle are going to have to add up to 180. So we have the 62, we have the 64, but we want to find this portion. So to find this, we're going to take 180 minus our 64 minus our 62. What do you end up with? So I got two different answers there. So do you guys agree with 54? Okay, so if you didn't get that, it might be parentheses. This is going to be my guess. But I got 54 as well. So if this is 54, you know that this one up here also has to be 54. Okay. We also know, since it's a parallelogram, that this right here is going to be congruent to this right here. And this right here is going to be congruent to this. Do you want to go through and solve the rest of the angles that we might have to solve before we begin? Last step. So you know that this is now forming four triangles, right? So if we want to find this angle right here, we know it's going to be 180 minus 54 minus 82 or 28. So what is that angle going to be? It's going to be 98 degrees. And then these are linear pairs. So that means that this angle, angle here and the orange angle are both going to add up to 180. So we have 180 minus 98 gives you 82. And then you know that these are vertical angles, so you have 82 here, and you're going to have your 98 down here. Okay, now we've solved everything that we should need to go down here. So if you're interested in finding angle MCT, so angle MCT, what is our measure? So remember, this is angle M, C is within the middle, T is down here. So what angle do we have?
62.
You have 62. And then we have CAR. CAR. So it's the total measure of this angle. 64. And then we have AMR. AMR. Could be 82. And then we have ACR. 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 So what's this portion? 54. And then we have ACT. ACT. So it's this whole angle up here. So that's going to be 62 plus 54. We didn't calculate that one. It's the 116. And then we have CT. So we see, yep, CT is going to be 12 because opposite sides are congruent. And we have TR. It's going to have to be 10. So the next group is determine if they're polygons and name them. So yes, she already told us it's an octagon. You'll see that it has 8 sides. No, not close. Nice job. No, and how do you know? Yep, not segments, not formed by segments. And then what is that one called? So this is yes. And how many sides do we have? We have 7, and what do we call a 7-sided object? Heptagon. Okay, over here. Some of these left off information, guys. I apologize. You need to know that this is 72 degrees for us to solve this. And this one over here, you have to know that this is right, and this is 32 or 37 degrees. I don't know why it didn't copy them in. I think that's all we have to add for right now. Down here, I'm going to make you add 8 and 5, but we'll deal with that when it comes. Okay, so up here, we want to find that missing angle measure. So you have 110 plus 65 plus 72 plus x equals 360. How much did you get? You said 247 plus x equals 360. 113. Thank you. So we end up with 113 degrees. Well, don't need it that way. Over here, we want to find this missing angle. That's going to be your x. So you have 360 equals x plus 90 plus 90 plus 37. So you have 217 plus x equals 360. You have 360 minus 217. What'd you get? 143. Okay, now we're down here. It's a parallelogram. Let's see what it's asking us to do. Find the measures. So it's leaving out the little angle marks in these. I don't know. Again, it has them on my sheet, so I'm a little confused why they're not on yours. So it has the angle marks that are supposed to be between these. If this is a parallelogram, you know that opposite angles are. So that means the angle C has to be 122. You know that consecutive angles are supplementary. So we have 180 minus 122 to find angle D. When we do this, we end up with 58. So this is 58, and this is 58. So angle B is 58 degrees. Angle C is 122 degrees. And angle D is 58 degrees. On our number 8, we see that we want to find PS. You have to know the value of the two things we added in. So So what is PS going to be? So opposite sides are congruent, so it has to be 5. SR, opposite sides, so that's going to be 8. Over here we have QS. So what's the total length of QS? It's going to be 6 because these parts are congruent.
Wait.
Because TQ is 3, that means TS has to also be 3. So it's going to add together and get 6. And then we have TR, which has to be 4. So we got 5 because we added it in because that was something that was left off the picture. So it's on the side. The purple stuff was stuff that should have been given to you. Segment. Do you guys remember your mid-segment formula? That is that 1/2 base 1 plus base 2. So you have 1/2 times 14 plus 22, which is going to be 1/2 times 36. What is half of 36? That is the square root of 36. What's half of 36? It's going to be 18. Over here, we have a property of a rhombus. We learned the other day that the diagonals do what to the angle? Do we have that property? Does it have that one under that one, underneath rhombus? Bisects a pair of opposite angles. Okay, so we see, I'm going to actually just give you this portion here. It'll make me feel better. I don't remember if that was supposed to be given or not, so we'll leave it as that. So we see here that we have 40. With it being bisected, that means that this one's also going to be 40. This one's going to be 40. This one's going to be 50. So our questions ask, what is the measure of AC? So what does the side measure of AC have to be? So if this side is 5, AC also has to be, because rhombus have 4 equal sides. And then we have the angle AC, ARC. ARC is how much? 40 degrees. What is the measure of RAC? So it's going to be 50 plus 50, which is 100. And then we have ASR. ASR. So we're looking for this angle here. We didn't solve for that yet, so that's 180 minus 50 plus 40. That's parentheses, so it's 2 subtractions there. So 50 plus 40 is 90. What's 180 minus 90? It's 90. Okay, over here, again, I hope that I gave you all the information you need. If not, we will talk through it. I'll see what else has to be given. So what do we know? So we know the other sides that are opposite have to be congruent. So we know that this is 3 and this is 4. We know that our diagonals are congruent. So with this, you have a right triangle being formed. So there is a rectangle. You have one leg as a 4 and one leg as a 5. How do I find my hypotenuse? We did a problem like this. How do we find our hypotenuse? Pythagorean Theorem. So you're going to find AC because it is the square root of 4 squared plus 3 squared, which is 16 plus 9. What is the square root of 16 plus 9? It's just going to be 5. So you know that AC has to be 5, which means that BC is also 5. What is BE going to have to be? It's being bisected, so that 5 is being cut in half. So it's going to be 2.5. I'm going to look in the hall. So this tells you that this is a rectangle. We see that it's a rectangle, and we were given the side lengths of 3 and 4. We want to find the lengths of our diagonals. How do we go about finding the lengths of our diagonals? So remember, in rectangles, your diagonals are congruent. Yep, Lanaya? It's okay. Today I'm not going to keep score with our usual point system, so I want to make sure. So what'd you say? So what is this form if I covered up this lower half down here? What is this form? It's the hypotenuse of a right triangle. So what do I use to find a hypotenuse? The Pythagorean Theorem. So for the Pythagorean Theorem, we know that that is a squared plus b squared equals c squared, where c squared is our hypotenuse. So we have where we're looking for AC is going to equal the square root of 4 squared plus 3 squared plus, which is going to be equal to the square root of, which is going to be, so we know the whole length of that diagonal is going to be 5. So we know AC is 5. Along with that, we want to find the length of just BE. Remember, in all the diagonals in a rectangle are congruent, so both diagonals are congruent. And if they've been bisected, it means all 4 of these little pieces are going to be the same. So if the whole thing is 5 and it's been bisected, cut in half, how much is that half? 2.5. So that means up here, this is going to be 2.5, which means that BE is 2.5. So our next one, I'm going to try to do this in different colors so we can see it as we go. We're looking for BCE. So BCE, that's this angle right here. How do I go about finding that angle? What'd you say? There's a right angle there. So we have a right angle, which is 90 degrees. And we're going to subtract the angle we have to give me what? 60 degrees. So we know that this angle is going to be 60 degrees. So we did that because we know that in a rectangle, you have 4 right angles. And then we have half of that angle is going to be 30. On the next portion, we have BCE. So BCE, so BCE, that's here. We want to find this one as well. So this one's a little trickier to find. You know, over here we had 60 degrees. You know that these two sides are congruent. Angles opposite of congruent sides are. So that means this is also 60. So this one, 180 minus 60 is? It's going to be 60. Remember, that's an equal angular triangle. Okay, so we have that. So we have BEC. It's going to be 60 degrees. We also have CBE. CBE. What's that one going to be? Oh, I'm sorry. I didn't color code this one. We're at CBE. CB. It's going to be 60. Because that's that pink angle up here. CBE. So right here. I'm going to color code the next one again. I'll do better. We have EBA. EBA is up here. And we have to figure that one out next. So we can look at it and we know over here, this one here, I'm pointing on my screen but you can't see it. This one's 30. That means this angle is 30. And then sides opposite, or angles opposite congruent sides are. So that means this one also has to be 30. So right here we have 30. And over here we have 30. So we know that that is going to be 30 degrees. We also have, let's see what color I might not have used, CAB. So CAB is this angle up here, one we just found as well. What's that one going to be? It's going to be 30 as well because it's CAB, 30 degrees right up there. And the last one in this section, we're trying to find BEA. So BEA, how do I find this one? Yep, add and subtract 180 minus my 2 angles I have, which are 30. This 30, which is 60. So 120. 180 minus 60 is 120 degrees. So here, what do we know about these 2 angles?
They're consecutive.
They're consecutive. We know consecutive angles are? Yep, 180. So we're going to solve for x. So we have 2x plus 52 plus 4x plus 4 equals 180. So to take those 2 angles, we're going to set them equal to 180, and we're going to solve. When we do that, we end up with 6x plus 56 equals 180. Subtract 56. We get 6x equals... Did you get 174? I got some. I got 124 as well. Yep. So we're going to divide by 6 and see what we get. X equals.
Hold up.
I got a decimal answer.
20.7.
Yeah, I put 20.7. And then now we want to find the measure of angle UDT. UDT is this top angle. Let me color. So UDT is right here. We know in a parallelogram that opposite angles are congruent. So the angle I want to find the measure of is UST because we know it's going to be the same measure. So we can now substitute in. We have 4 times 20.7 plus 4. 86.8. Okay. And that's because those are opposite angles are congruent. Our next one is SUD. And that is going to be this angle up here. And again, we know opposite angles are congruent. So we know we can do 2 times 27.7 plus 52.
Oh, where do you get the 2? Oh.
So we're using that formula. And what'd you get, hon? 93.4. Okay, our one over here, we have a square. Inside the square, we had to have drawn those diagonals. They were on the screen. That's one of the things I asked you guys to update a couple minutes ago. So if you didn't do that at the beginning, I'll draw them back in. You see that this is a side is 6. We want to find the rest of this. So let's start with the perimeter. What's going to be the perimeter of our square? So remember the perimeters, the outside lengths. So we're adding up them, and we know in there we have all the sides are going to be the same because a square is a rhombus and a rectangle. So it's going to be 6 plus 6 plus 6 plus 6. 24. Nice job. Okay. And then we also have where we want to find our angles. So when we have the diagonals of a square, they form a special triangle. What triangle do they form? A special type of that. Remember, this is our special right triangle it forms? Do you guys remember what special right triangle it is? Nope. Equilateral. So this is one where we had those special numbers that go with them. So we learned 2 special right triangles. I'll give you that this is the 90. What's the other ones?
60 and 90.
Not for this one.
60 and 40.
Yep. So this one's the 45, 45, 90. So remember that means that all of these are 45 degrees. You don't have to continue this on as long as you can see it. I'm doing it to make sure that you guys know that all these are going to be 45. So up here, we want to find the measure of angle ONL. ONL is this angle right here. What's the measurement of that angle? 45 degrees. Okay, and then we want to find the measurement of MNL. That's this angle right here. What is that one? It's going to be 45 as well. And then we want to find NQM. NQM is this angle right here. It's going to be 90. And then N, because remember that that last one is 90.
Where you get one of?
Oh,
you added it to?
Yeah, it's given.
Oh.
Okay, over here we see we have angle D and we have angle B. We want to find angle E and we want to find angle C. So we know that these are parallel lines because it's a trapezoid. You have one pair of parallel sides cut by a transversal. What's the relationship between these two angles? They're going to equal 180. So we take 180 and we're going to minus 63 and we're going to get the top angle E.
No, it's not.
Yes, it is. How you gonna tell me?
She's going to be correct. It's 117.
I just said it was 117.
Okay, ladies, please. 117. Okay, over here, we want to find angle C. We know the same thing's happening here. Parallel lines cut by the transversal. They're going to be supplementary again. So that means you have 180 minus 104, which gives you?
76.
Nice job. 76. Okay, and then this one is going to be an isosceles trapezoid. Remember, we had special properties of isosceles trapezoids. We talked about them specifically yesterday. Remember that you have 2 congruent sides, and then your bases are parallel because that's a property of a trapezoid. We know that we have angle measure of 72 here. What other angle is going to have that angle measure? J, K, or L. So be careful with this one. So it's going to be L because base angles and isosceles trapezoids are congruent. So angle L is also going to be 72. So we can go over here and add in a 72 degrees. How do we go about finding our upper base angle? So what's the relationship between these two? They're supplementary, so we have 180, which gives you 108. This one's an upper base angle, so that's also 108.